Right. There've only three of us, but I must start. Otherwise, we're going to run out of time. So, firstly, the first thing that I want to do is I want to choose another ligand to dock that's not one of these five. And so I have been to zinc, and I've got 100 from zinc, 100 molecules from zinc. And so those are on the cluster as an SDF. I've already copied it to the cluster. So I'm going to go back to the cluster now. And I've got it in a folder. Right, so if I just list what I've got there, it's in this folder called multiple. So you see this multiple, that's where I've placed the SDF from zinc. Okay, and there it is. It's called moles.sdf, and it's straight there from zinc. So the question I have is, there are 100 molecules in that file. And so what can I, which one of those should I choose for molecular docking? Well, several of them may be great for that, but let's see what we can do. I'll just show you that there are many of them, because we can do Babel, the input as an SDF, moles.sdf. The output we can have as a PDB. And we just have, I'm going to call it mol singular.pdb. And I'm going to put a minus m there for multiple on that. Okay. And then what happens with that is it's going to create multiple. It's going to create 100 PDBs with different names. And I'm doing this in two stages to make sure that I've got access to every ligand individually. And they're the 100. And so we've got, this is too much to do by hand in terms of molecular docking. You might notice that when you installed Autodoc tools, other tools came too, and some of those are for high throughput screening. So if you were adventurous, you might be able to take all of those and use some of the tools that are available when you installed Autodoc tools to do high throughput screening. But of course, one by one, it's a little bit tricky. So we need to decide which one of these is good for molecular docking. So what I'm going to do is I'm going to follow that command that I had, which is Babel minus I PDB. And let's take all of those PDBs as star.pdb, convert all of those PDBs into one SDF file. The output is an SDF file. And the name of that file I'm going to call properties.sdf. And I'm going to then double dash add to it the properties like A bonds, log P, log capital P, molecular weight, hydrogen bond acceptors, that's HbA1, hydrogen bond donors, number of hydrogen bond donors, the topological polar surface area, and I'll see if I can get a title as well. Okay, and it's managed to do all of that. So I need to have a look at that properties.sdf file. I need to have a look at it. You can do less on it, but what I will do is I'm going to open it using WinSCP. Okay, just give me a moment. Okay. And it's in here. And if I just go down now to the bottom, there it is. What I'm going to do is I'm going to right click on it and go edit. I'm not going to really edit it. I just want to have a look at it. And as you go through, you can see there's mol1.pdb. Let's try and decide whether mol mol100.pdb is a good one to use. And let's go down and we see that we've got no hydrogen bond donors. We've got 5 hydrogen bond receptors. So those all seem to be fine in terms of Lipinski. This is less than 5. Log P is less than 5. Molecular weight is less than 500. If you look at the variants on Wikipedia for Lipinskis, you'll see about the polar surface area being less than 500, and that's fine. So already, in terms of this, I have determined that this is a fine molecule to dock. This mol100.pdb that I've managed to get from okay. So this, you just have to be happy to open the SDF and scroll past the coordinates. You see the coordinates there, and go down, and the command that we've just done has added all those properties to the SDF, and we have it there. And I have determined that the drug-like properties of mol100.pdb are really good. And so the question now is, mol100.pdb a really good, is it a good molecule in terms of binding to receptor? So I'm going to try and bind mol100. I'm going to try and dock mol100.pdb to my receptor 5-REC. Okay, so let's now close it. And what's important is this mol100.pdb. There it is, right at the bottom. That's, we've determined by looking at its physicochemical properties that it has the right properties. I'm just going to copy it locally to my local computer. There it is. And then on the cluster, I want to create a brand new folder that's got everything I need to work with. So let's just see. So this is, create a new folder, new directory, and I'm going to try, I'm going to call it the next docking. Okay. So there is next docking, and I want to dock mol100 against 5-rec apo. There it is, 5-rec apo dot pdqt. So I'm just thinking that maybe what I should be doing is starting from scratch. Just to let's go with 5-rec a.pd. So right. So I'll take that pdqt so that we've got just the A conformation and that, and we have that as well. Okay. So let me then change directory here to next docking. Hang on. I'm going to need to go down one folder, so I'll cd ... and then I'll cd to next docking. And we've got those two there. Okay, so the first thing that I will do is I'm going to just do this module add autodoc mgl tools and module add autodoc genome. So I've got everything I need to do molecular docking. And so now for the ligand, we go prepare ligand 4.py minus L, and it's mol100.pdb. Give that a moment, and we've got that. And now we've got prepare receptor py. Okay, and just a little thing is that if you can't remember what to type with prepare receptor, just leave it like that and press enter, and it'll tell you what's all there. And so we can go prepare receptor and minus R, and it's the 5-rec.pdb. Then I'm going to try the -O again. Let's see if it'll work. If it'll actually give me the 5rec A apo.pdbqt. I'll see if it works this time in this order. And of course, what we want to do is we want to clean up with the A, we want to clean up the hydrogens at least. The cleanup type here is -U. We can do waters to get rid of the waters, and the -E we want to delete. True. Okay, we can maybe refine that. Let's see if that works now. And now it didn't give me the right, yes, it gave me the right name. So typing this order has given me the right name for, there's my apoprotein. It's deleted. There it is. There is the receptor that we've got as well. I just want to have a look at the 5rec apo. I just want to look inside it because I noticed that it has not deleted the standard residues. So I've done something, it hasn't done everything right. Okay, can I just see? I noticed that it didn't give me the message that it hadn't deleted stuff. So I think that I've done something that is not perfectly fine in this. Just give me a moment. So here we go. Apologies. I'm just trying to remember what I typed the last time. It's obviously not picking up. Let me just try and take out that O and just let it give it a default name. Okay, so what have I done differently from last time? Please, anyone comment? Yes. Any comments? Those of you in the notes, what did I type exactly the last time?
From these talking or the ones you did yesterday?
To prepare the protein. I'm going to go. There we go. No. Prepare GPF. Prepare receptor 4. That's what I typed.
Oh, you missed the 4.
Ah, that's what I missed. Thank you. Thank you. My apologies. Thank you very much for telling me that. You see, what was bugging me, what was concerning me is I did not see this line here. And so I knew something was terribly wrong. And it would have been disastrous if I'd missed that 4. Thank you. If I'd missed that 4, it would have been disastrous because those molecules would have remained present in the system. And if those had remained present, then of course our molecule would not have worked. Okay, so can I just remove I just want to remove so just to make sure that I'm doing everything, that I'm not using, and that's not a PDBQT, sorry, that's because I'm not using the right tool. And I'm going to remove all receptors, and let's try it from scratch. And let's try that again. So this one here, it's prepare receptor 4. Thank you. Okay, so here we have it. It's called 5rec A. I didn't give it the correct name. I'm just going to move it to 5rec A. PDQT, I'm going to move it to 5rec A apo.pdbqt. I'm going to rename it. You can rename it in WinSCP as well. But what's nice is at this point, I have got a ligand and I've got a protein PDBQT. So we are perfectly set. then to do an Autodoc Viner. So Autodoc Viner, let's just see how we're going to do an Autodoc Viner. So here's WinCP. I just need Notepad++. So let's just see if I can start Notepad++. And I just want it smaller so I can see what's going on. I'll just start with a new file. I'm going to make it small so I can see what's on the left here. So what I want to type in here is I want to type receptor. The receptor is 5rec a apo.pdbqt. The ligand is mol100.pdbqt. Right? Okay. And let's say the output, we've got to just remember the output. When we come back to this, we need to remember that's mol100 to 5rec A. So I'm going to do it 5rec A. The output is 5rec A, and with mol100.all.pdbqt. And I'm call it out, not output, out. Okay. And then I know that that file will contain all the outputs between docking of mol100 to 5rec A. And there's a log file just for interest. I'll give it the same name, 5rec A mol100. And I'll put it with the log name.
I told you to do it the other way. Do it.
What
Like that.
What the other way? Sorry, there's a question. Right. Now we just need to make sure that our yes, a question. Okay. Now our center for docking, we center X, the center for X is 23.0. The center for Y, please spell center in this way, is equal to 15.0, and the center for Z is center for Z is 4.5. I think that was my estimate. Then, of course, you've got to have the size of your search area. So size X is equal to, please use underscores there, not hyphens, 22 angstroms, very large search box. Size Y is 22, and size Z is 22. There we go. And energy range, I think this is for clustering. You can look it up. But the exhaustiveness, I'm going to put it as 32 for now. It's quite a long docking. Let's see how well it works. And then I'm going to do the CPU as equal to 8 in case I want to submit it to the cluster. Please, and some files, in some systems, having some blank lines at the end helps. So maybe not for here, but for other cases, I always tend to put a blank line at the end. We'll save it as, and I'm going to call this this was 5rec A, and that was mol100, and I'm going to call it .viner with a .viner extension. Okay. So here it is. It should be somewhere on my folder. Where is it? Where's that Viner file? It's 5rec A. There we go. It's got a text extension on it. We've got to be careful with that. So it's been saved as a text. I'm just doing F2 to rename it and to remove the .text. It must just only have a Viner on the end. Okay. And I can copy it across. And now we're good to go for Autodoc Viner. Okay. If you want to run it directly on Carbon, be careful. There might be lots of people running on Carbon. You could do Viner. You just do Viner. There it is. You can see it. There it is. 5rec A. There's the Viner config. So what we're going to do is Viner minus config, one word. And then I'll just paste in that Viner file. And let's see what happens. The moment you press enter, you can see the molecular docking is occurring. And you can estimate how long it's going to take. It's not going to be long for the molecular docking to be complete. You can also set up Viner runs within Autodoc tools, but I don't tend to do that. I tend to use text to set it up. If you mistype something, you'll get an error here, and then you go back and you very carefully check what you've mistyped. Okay. If it fails, please don't email me that it's failed. Please send me your Viner file. Email it to me, attach it to an email and send it to me, and I'll be able to tell you why it's failed. Okay. Right, so there we go. So you can see that it has got 9 binding modes. And of course, the best energy is minus 5.8 kilocalories per mole, and the worst is minus 5.4. But it might be nice, you see, if you want to compare, you'd redock the original ligand, and then you'd be able to compare, is this new ligand, is that better than the original one? Okay. Right, so now what I want to do is I want to have a look at what's created. And can you see there's the log file that we have? Let's have a look at the log file. Just refresh, see what's in it. The log file just keeps record of those numbers and how different these numbers, the RMSD, this is how different this binding mode is from the first binding mode. So that's really interesting. But what I find interesting, I tend to go for the mode 1, the lowest energy mode, the one that's at minus 5.8. Okay. But of course, that means that this all.pdbq, this output here, contains all 9 of them. So this all.pdbq here contains 9 structures. And so what we use is we use Viner or Vina split. If you type it without anything, it tells you what to do. And you type Vina split minus input is what it tells you to do. And then the name of the file to split. Okay, and when you do that, if we come back to here, you'll see that it's now split that all.pdbqt into ligand 1, which is your best binding, all the way to ligand 9, which is your worst binding. Okay, so I'm going to copy ligand 1 right the way back. Okay. So there are a couple of things that I can do at this point. And one is that before I go off the cluster, I just need to remind myself of how to, just give me a moment. There we go. So if we go here, what I'm going to do is, let's see if Babel can convert minus IPDB. And let's take that best binding one. And let's see if I can output as a mol2. And let's just see it as a mol2. Yeah, it converts as a mol2. Let's just see then if X-score works. No, it's not found. Okay, if I had X-score, I need to check where X-score is on this. Maybe it's in the module. Yes, I do. Module add, there we go. Then if you module add X-score, then you can do X-score minus score. What's the name of the protein? It's 5-rec. Hang on, but we need to have a PDB format for our protein. So I'm going to just, if you have a look at your protein, the protein is here, 5-rec apo.pdbqt. I need a PDB for X-score. So let's do Babel minus IPDBQT, that minus output as a PDB. Okay, minus output PDB, so output PDB, there we go. Right, now I can use X-score because X-score then takes in a protein, which is 5-rec a apo.pdb, and then it takes in a ligand and a mol2 format. Here is the ligand as a mol2 format. And X-score now has told me, and this seems to match, well, it's not surprising since Autodoc Vinus scoring is based a lot on X-score, but you can see X-score has independently of the docking program, it has independently predicted a binding energy. Okay, so if you're brave, get your apoprotein as a PDB, get your ligand as a mol2 using Babel, get your best ligand as a mol2, and then what I typed, I'm just pressing up arrow to show you, I typed X-score, space, minus score, the apoprotein as a PDB, the bound ligand as a mol2, and then it provides all of this information about the binding energy of your ligand. So there's a lot more information you can get about that. But what I'm interested now at the moment is I want to take this back. That ligand number 1, we've got it there. We have it as a mol2 or as a PDB2. I want to bring it back here. Yes, because another tool that you can use to work with is Discovery Studio Visualizer. And please, with this, it's nice to have a file hierarchy on your computer because it means you can drag multiple files into one system. Okay, so let's go file. So I can't see files, the file visualizer over here. So I'm going to go view and explorers and have the file explorer here. Here's the file explorer. Because then when I go to my folder, let's make that slightly bigger. There we go. I can find the apo.pdb. I open the apo.pdb, there's the empty protein. Then you can just see here's the ligand that I docked. All you have to do is you just have to drag it in. And there you can see it right there. There is the ligand with the protein. But of course, you've got these tools now. So what I did was I just double-clicked in the file menu to open the apo protein. There's the apo.pdb. And then I dragged in the docked ligand. And you could drag in the co-crystallized ligand as well to see how it matches. You can see that this here is a new molecule, a brand new molecule, and it's going roughly to the same, it's in the same area, binding site is the co-crystallized, but it's providing, so you have some measure of comparison between the two. I just want to take the co-crystallized ligand out. I Control Z to undo what I've done. Because there's more that you can do. There's a button that says receptor ligand interactions. And in your receptor ligand interactions, you need to be able to select your ligand. So if your view and hierarchy is not available, just go to view and go to hierarchy so that you can select the ligand alone. Because then you can define what your ligand is. And then you can look at the ligand interactions. And so this is just showing me the residues that are interacting with that particular ligand. Okay, and I'm just trying to see what I can undo. Okay, let's maybe show receptor surfaces. Let's see if there's a receptor surface. You can see there's a surface of a protein and where it's interacting. You can expand and you can change the visibility. You can see the protein again. So this is a very powerful way to view how your molecular docking has proceeded. Are there any questions?
Prof.
Yeah?
Oh, I wanted to ask. I think I'm just one or 2 practice lectures behind.
Okay.
Um, when we're preparing these proteins, right, we can prepare
Yes.
them in Autodoc as well as at the cluster, right?
Yes, you can.
Okay, fine. I wanted to ask, when you prepared this protein, the Apple PDB, you took it as a PDB file, and then the output was a PDBQ, right? Here on
Yes,
the
yes,
cluster.
yes.
Can I take the PDBQ that we made in Autodoc
Yes.
tools and then use it as well on the cluster when I'm
Yes, you
doing this?
can. It's the same thing.
Okay,
It's 2 ways to perform the same task.
same task. Okay.
Yeah.
Another question was, I saw you were doing the 100 ligands
Yes.
that you downloaded. I wanted to ask, I think the last time in one of your practice lectures, did you talk about how you converted them to from the XYZ, because that's the last time I did mine, from the XYZ format? Because when you downloaded it, oh, it's SDF, right? And then you
Yeah.
change them all to
XYZ.
XYZ. Yeah,
Okay,
XYZ.
so
And then from,
can I just show you? If I go
okay,
into multiple, in my old here, I'm going to change the old directory here. I've got a whole lot of XYZ. So I'm just going to make a folder and just move startup PDB to a PDB folder. Okay, so in here, I've only got XYZ. And these XYZs that I've got here are from, I've done use XDB on them, actually. No, I think these are from, but your Babel will work here. You can do Babel minus I XYZ, star.xyz, minus out SDF, properties, dot SDF, and then add, and then what we had is things like topological polar surface area, for instance, and molecular weight, for instance. You could add those, and then what's happened is if we have a look in properties.SDF, you'll see that if you go down, if you look at Notepad++, you can see that it's added those 2 properties. It's calculated the properties and added them to the output SDF. So this here is a way that you can take XYZ files and add them to a system. Okay.
so then from there, we can make them into PDB files.
You can make them
Because
to PDB as
my
well.
question was, I can see that in like the previous directory, you have like XYZ and PDB.
Yeah. So
Yeah.
it's a process. I don't know how to do. I only know how easily how to do them individually. So
Oh, so we do them individually. That's what I wanted
yeah,
to ask.
yeah.
We do every
So
one of them
yeah.
individually to PDB.
If you have ever done Python or shell scripting, then it's an easy task. But without having done it, it's one by one. So what I suggest you do is have a look at your, or maybe there is a way to do it. You know that I created that, so you see, I've just created properties.sdf from the XYZ.
Yes.
So how about this?
Yes.
Babel minus ISDF, properties.sdf
Yes.
minus O PDB,
Then we do PDB.
mol.pdb, and ask it to do multiple.
Multiple.
The thing I would be worried about in this case is the mol 101, does it match exactly? I think that the numbers may not match. You've got to be careful, so that the mol 13 XYZ might not be exactly the same molecule as mol 13.pdb. I just want to have a look.
Oh, okay. So, yeah, because there's like 101
it might be
output.
4.198. Just hang on. No, these are 2 different. So it may mess up the order of them. So maybe only converting the molecule you're interested in is probably a safer way to work. Unless you're not worried about the order, you change them to PDB, and then you start worrying about properties in the order of them. That might be
Okay.
the way to work. Okay.
Okay. So then from the PDBs, we can now optimize them even on
Yeah. Yeah.
the cluster or on
Yeah.
Autodoc.
Yeah. I think
Okay.
if you've got a lot of them, I think the best thing to do is to you could optimize it here. So you could do module add XGB. Sorry, our meeting has got 3 minutes left, and then you can do XGB minus opt. Just remind me of the XGB. It's XGB, it's mol 100, isn't it? Mol 100.xyz minus opt. Okay, so we've decided on that. We don't have to. And then what you can do with that is then, of course, that creates the XGB opt.xyz, and so you then do Babel minus I xyz XGB opt dot xyz minus O PDB mol 100 XGB dot PDB. And then that's it's good for docking, and you can go prepare ligand 4 PY minus L mol. And so I've got that now all set up for docking. Does that answer your questions?
Yeah, it does now. So the safest way is to just work with one ligand at a time.
Yeah.
Because as well as at the XTB there, you're gonna have, if you try to do them, they're gonna keep replacing that XTB.
Absolutely, absolutely, yes. Okay. So so it might be worth calculating the properties of a ligand first and making a decision on a small set that you're going to work with, and then only optimizing those and working with those later. Okay.
All right. Okay. Another thing.
Please detail exactly what you've done when you do your write-up. Okay. So I can follow your train of thought going through. Okay.
Okay. Okay. So now that we have that XTB, PDB, we can just now be able to change it to PDBQ, and then it's already ready.
No, I've changed it to PBQT by using prepare ligand 4. Please use prepare ligand to create PBQT.
PDBQT. Yeah.
Yeah, because I trust the way that MGL Tools sets up the torsion angles.
Okay. All right. Thank you.
Okay, perfect. Okay, I think we're out of time. So if there are further questions, please email me and I will respond to that. Okay.